Let's do example 7.10. Route 3 highway on a ramp, a car of mass 1.5 times 10 to the power 3 kg is stopped at a stop sign, waiting for break in traffic before waiting for a break. Is stopped at the stop sign, waiting for a break in the traffic before merging with the cars on the highway. A pickup, another car of mass 2 times 10 to the power 3 kg, comes up from behind and hits the stopped car. Assume the collision is elastic. If the collision is elastic, this means that we need to it's elastic. We need to consider a conservation of kinetic energy. How fast was the pickup going? How fast was the pickup going just before? So how fast was the pickup going just before the collision? If the car is pushed straight ahead onto the highway at 20 meters, just 20 meters per second, just after the collision. So we want the initial, because they say before the collision, so we want the initial velocity for the pickup the car, the van. So, and here we need to consider conservation of kinetic energy as well. So let's calculate maybe the momentum before. Momentum before. Before. So we'll have that the momentum before. So the initial momentum. So I need to add. So we'll have momentum due to mass 2 initial plus momentum due to mass 1 initial, and then we have, because momentum is mass times velocity, so we'll have that mass 2 times v21, and then we need to add, this is a vector, so we need to add, so when you add so we added mass 1 velocity. Can we write them in a scale of quantities? So this will be 1 initial. So from here we see that the initial velocity for the this will be car 1 and this will be car 2. For car 1 is 0, so we need to simply this will be 0, and then so we have that the initial momentum will be v2I. So actually this is what we are required to find, but then we need to find the final velocity now. So so we have that the initial momentum is m2 v2I. So let's go and calculate the final. So now the final momentum to be the sum as well. So this is, remember, this is car 2 and this is car 1. So it will be momentum due to car 2 final plus momentum due to car 1 final. So we have see if we are given. Okay. So we are given, assuming the collision is elastic, how far was the pickup going just before the collision? And if the car is pushed straight ahead onto the highway, so this is pushed. Okay, we're given this one. So we have m uh, we have m2 v2 final, and then plus m1 v1 final. So we are given, which is this. So and then, but we are not given the final velocity of this car. So now we'll have, okay, let me check if they did. So as I was saying, okay, so this is the equation that we will have. This what will, so we'll have m2 v2 initial, which is equal to m1 v1 final plus m2 v2 final. So now because now we have two unknowns, which is two unknowns, we don't know the initial, which are required initial velocity for car 2, and also we are not given the final velocity of car 2. So what we'll do now is to use the conservation of kinetic energy, which is so we need to use the conservation. So we need to use the conservation of kinetic energy that will help us to solve the two unknowns. So what we'll do now is that the initial, let me say the initial kinetic energy, it will be half m1 v1 initial squared plus half m2 v2 initial. So remember that for mass, because the car 1 was standing, so this will be 0. So this will be 0. So we have that. So we will have that the initial kinetic will be m2 v2I. So now we need to calculate kinetic final. So let's call it kf. So now this will be half m1 v1 final squared plus half m2 v2 final squared. So again, okay, we are given this. We are given the final velocity of car 1, which is this one, but we are not given this. So let's equate these equations and see what we get. So let's equate the final kinetic to initial kinetic. We'll have something like okay, let me write here. So you need to say k initial equal to k final. So remember that k initial was, okay, let me write it. So k initial was half m2 v2 I squared, and then we need to equate it to the final kinetic, which is half m 1 v 1 final squared, then plus half m2 v2 squared final. So now so we need to sort this part. So we need to sort this part. So what we can do is to sort this part. We can because what we can do actually is to take this part and then make v2 final the subject to the formula, and then we take the square of that, so we square it. So we need to make this subject to the formula and then square it, and then after squaring it, we come back here and substitute here and then multiply. So but before we even do that, let's simply cancel the halves because they are common. Cancel the halves, and okay, then let's go from there. So when you rearrange this equation, so when you rearrange this equation and make a v, made v2 final, it's the subject of the formula. Okay, maybe let me do it. So you have v, you have v2 final, which is equal to m2 v2 initial minus m1 v1 final all over m2. And then what the next step now, so the next step now is to square this, which we need to square this. And when you do that, when you do the square, the squaring, so you will find that v2 final squared is actually, okay, I hope will do this. So it's equal to v2i squared minus 2m m21 like here. So it will be v2i v1 final, and then plus m2 over so it will be okay, this will be m squared 1, so this would be squared 2, and then say times v1 of final squared. So when you do that, you will find this, and then you take this and then you take this equation, or this equation, which is simply means v2 final squared, and then substitute it into, remember, the equation we obtain from equating kinetic energy before and kinetic energy after. So in that equation you need to plug all this. So when you do that, we'll have expression we got, which of expression of v2 final squared, and when you plug in and then multiply by m2, So what the expression you will get is actually okay. When you do that, when you substitute and then you, okay, maybe let me write it because take, okay, there's a problem here. Should be okay, there should be all right, should be this should be 1. Okay, this should be 2. Okay, this should be 2 initial. Sorry, this should be 2 initial here. So that this will cancel this. This will be 2 initial. So this will cancel this, and then you'll get that you cancel out, and then you have 0 on the left side. And then what we will another thing that will then cancel out when the left side is equal to 0 is this, the m's, the m1, this m1, and then there is another m1 here, and another m1 here, but here will be left, because it's squared, will be left with m1, just m1. So then the equation, the new equation, let me write. So the new equation will be so the new equation will be 0 is equal to m1 of v1 final squared minus 2m1 v2 iv 1 final, then plus 1 2 over m2, okay, and then v1 final squared. And then after that, after this part, you can see that now, because we have v1f squared here and then v1f squared, so we can group these terms. So when you do that, when you group this term, we have 0. Oops, we have 0 is equal to, and then now we group the term, so we have this equation now, m over m2, then we have v1 final squared, then minus 2 times, okay, let me write the 2 times here, so it will be minus 2 times v2 initial v1 final. So now you can see that if we cancel this and cancel this, so here, so up here we'll have, so here will remain 1 final. So the new equation, will be 0 is equal to 1 plus m or 1 over m2 times v1 final, and then minus 2 v2 initial. So now you can take a v2 by that other side, so we'll have this equation. So we'll have 2v2i equal to, and then another thing, I think you noticed that m1 over m2 can simply, because it's 1 over 1, you can simply say times m2 over m2 to make it the same denominator. So then you will have m2 plus m1 over m2. So now you will write this expression as m2 plus m1 over m2, then times the final velocity of 1. So, and then you divide by 2 both sides. So when you divide by 2, so you need the next step is to divide by 2 both sides. So this 2 will cancel this, and the final equation will be, so the final equation will be v2I is equal to m2 plus m1 all over 2m2 and multiply v1 final. So this is the same equation. So this equation is the same equation as this equation. So and then you substitute the values. So you will get that this will be the initial velocity of that car, which is the pickup. So this will be the velocity before the collision. As you've seen that when you but it's not always, because remember there's a perfect elastic. Okay, always, yeah, you can always use this equation actually, but you see that when you compare initial kinetic and final kinetic, you'll still have the same answer. So I would prefer you using this method much as it is, but with practice you can do the calculation faster. So I prefer you using this conservation of kinetic and kinetic energy, and then yes, you will get the same answer. So now let's go over to the next problem. Okay, this should be the last one. And this one I will make separate videos for self-assessment because you also need help there. Okay, let's go over this one quickly. So here we're dealing with ballistic pendulum. The mass, so here we are given, okay, the mass of the block of wood is, this is the mass of the wood, 2.5 kg, and the mass of the bullet, which is 0.01 kg. So the block swings to a maximum height of 0.65 meter above the initial position. So above the initial position. So first of all, when they say maximum height, this means that it reached a height where it stopped swinging. So this would be the maximum height, where v final is 0. So there's no further movement up. So please take note of that. And then also another thing to highlight here is that here the set this position as a reference point. So that's why the height is the height we consider. So now you can see that you can then tell that the initial height when the bullet, so when the bullet is here, so this means that the initial height is 0 because we are using this position as a reference point. So this would be the 0 of the analysis of the coordinate. So okay, I wanted to touch those things. So now let's start. Okay, they want us to find the initial speed. So they want us to find the initial speed of the bullet. So we know that we need to consider, okay, maybe before I even talk, we go to the other side. So we need, as we have seen, because we want, remember we want v0 1, so we want the initial velocity of the bullet. So, and we know that the velocity, okay, and this we know that okay, so when we do that, we calculate, we equate actually, we equate the momentum before and momentum after. So here, this is, I don't know whether you see how this expression came about, but maybe let's do it. Let me do the steps. So okay, so this just check the initial momentum. So we need to add. So initially one is the plate and 2 is the wood. So we need to add the 2 momentum. So for initial we'll use as we've used here, they've used 0 for initial, so we'll use 0 as well. So 0 for the bullet, and then 0 2 would be for the wood. So this would be the momentum. So this would be the momentum for the bullet, initial momentum for the bullet. This will be the initial momentum for the wood. So as you can see, because the wood is stationary here, so here this would be 0, and yet so this reduces because you know that momentum is mass times velocity. So this reduces to m1 v and not 1. So this will be the initial momentum. So take note of that, because we'll need it later. So we'll need that later. So all right, so now let's check the final momentum, or the momentum before. So we've checked this is the momentum before, this is the momentum after. So now this momentum after, let's call it final. And so the momentum due to let's call it now final momentum due to bullet plus final momentum due to the wood. So as you can see that now they're together, they're stuck together. So they are stuck. This is an example of an inelastic problem. So there's no need, we don't need to use the kinetic energy conservation here. So now another thing to note is that because the bullet is stuck inside the wood, this means that they are moving together now. They are moving together, and by moving together, it means that they share the same velocity, which is vf. So they share the same velocity. So now another thing is, you can simply say the momentum now here is simply m1 plus m2, and take out the v final. So now we need to say, okay, this will be the final momentum. So now we need to say initial momentum is equal to final momentum. You see that? So when you do that, you'll get this equation. So you'll get this equation. When you do that, you'll get this equation. Now, because we want, then since we want the initial velocity of the bullet, so we'll make this the subset of the formula, make this guy the subset of the formula. So we have this equation. But as you can see, we are not given the final velocity. So but we are given that it have traveled at this height. So this means that we can actually, due to its height, we know its height, so we can calculate its final velocity. Because here, okay, here as you can see, so something we've learned previously. So here it had gained kinetic energy, and then it started losing kinetic energy and then gained potential energy when it reached the maximum height. So uh, there's kinetic and potential energy involved here. And you remember what is this is mechanical energy. So we can calculate, actually we can calculate uh, the mechanical energy before, and we can calculate the mechanical energy after. So we need to consider that, so that when we do that, because we will involve kinetic energy, which is will depend on this velocity, and then we are given the height and the masses, and then because they still share, it means because they still share the mass to m1 plus m2 even here. So this means that they will have the same mass. They have the same mass. Uh, they will have the same mass. This means here and here. It means that before and after they have the same mass. So there will be one unknown, which is to be the V final. So let's go over that quickly. I'm not sure if they covered, oh, they did cover that. Okay, so let's go over it together. So here can calculate the energy initial, and we can calculate here the energy final. So let's do that. So here we have that E initial, which would be the kinetic energy. Let's call, let's call m1 plus m2 as simply m. So this will be m, which is m1 plus m2, then v final squared, and then we have that need to add the potential energy, which is given by m, again m, to be the mass of both the the bullet and the wood. So and then this would be gravity, and this will be the initial. Let's call it h0. This will be the initial. Okay, call it maybe I. So it will be hi, which is the initial height. So as you can see, that this is 0 because we have used because if this is a reference point, and this means at this position this is 0, and then the final height is here. So this is the reference point. So the bullet is at 0 height here. So it means that we have that E initial, the energy initial will be the mass, the total mass, the final velocity. So this will be, and then we need to equate this to the final energy, which we'll obtain here. So we'll consider it here. So energy final will be, again, oh, maybe I've forgotten to use so let me rewrite, sorry. So I've forgotten to use half, because initial it's half, actually half m v final squared. So I've forgotten half. This half, this kinetic energy, so half. Okay, let's go to the final energy. So here we have half m v final squared. Oh, no, here we are here now, and then plus m g h final. So this is the final. So here we have that the final, let's call it the final one, or let's call it final one, because this final is different. Okay, here the velocity is different, so let's call it final one. This will be just final, this one will be final one. Yes. So final one is 0 because it has reached the maximum height where there's no further movement, so it stopped actually. So it stopped. Then the velocity when we stopped is 0. So we have that E final is m g h or h final. So now we need to equate it to this equation. So together this equation is check if yes. So together when you do that, you find that okay. So when you do that, you find that m, the initial, so because we say initial energy equal to final energy, so it will be m. Remember it's half, then squared, then the potent, then the energy final was m and g h final. So since the masses are the same, so they cancel each other, and then because we want this, so multiply by 2 both sides, multiply by 2 both sides, so we have v squared, which is equal to m g h f. Then you take the square root. When you do that, when you take the square root, we have f or vf as square root of 2g. Oh, here, sorry, here it's cancel this m's, so it will be the square root of g g hf, so which is this part. So then you can determine the final velocity. So when we get the final velocity, we go back to the equation we obtained, the first equation we obtained, and substitute vf. So when you do the substitution, you will get that the initial velocity of the bullet was this. So here I'll make a video on this part separately, otherwise I've covered this chapter or this unit. I'll make a video separately for this.